Hello everyone, I'm Kai Chen from the University of China's Academy of Sciences, and the authors of this article are unable to present due to some reasons, so I'm here to present the article on their behalf. The title of the paper is CASPR, Context-Aware Security Policy Recommendation. We begin with the background of access control based on SELinux. SELinux, short for Security Enhancing Linux, controls interactions between entities through security policies to achieve the least privilege and prevent unauthorized access. Each entity of access request has a security label. According to the types in the labels, the security policy implements privilege changes by tuning the mandatory rules. Therefore, it's important to configure proper policies to strengthen security. However, the large number of policy rules and the complex semantics make policy customization time-consuming and error-prone. Currently, most policies are configured manually. It requires expertise and increases the time cost of policy customization. To cope with the challenges, a large number of studies are related to policy analysis and the automatic recommendation of policy rules. However, previous works lacks policy recommendations for newly defined types, which lacks rules used as a reference. More importantly, improper policy will cause security problems. The access control policy determines the authority of the subject to the object. If the policy rules are over-privileging, it will lead to unauthorized access, data leakage, and malicious attacks. Conversely, if they authorize it inadequately, it will affect the normal operations of the system. Therefore, our goal is to recommend modifications of inappropriate rules for better management of permissions. In this paper, we connect 4 context-aware information related to privilege similarity, which are policy rules, file locations, audit logs, and attributes. Privileges are granted by policy implementation, so it's a direct indicator. Subjects with past dependencies share similar privileges. The behavior that occurred at the same time have been caused by the same event, which are allowed or denied together. The attribute definition takes into account the functional similarity of its containing type. Permissions are granted with the attribute as a unit. The context-aware information indicates more identical privileges. For privilege computation and policy recommendation, CASPR uses context-aware information as features and domains and object types as samples. We train a K-means model with a feature matrix of privilege similarity. To address the huge number of object types in SELinux, we adopt secondary clustering when clustering the objects of policy. CASPR not only recommends rules, but also performs anomaly detection to ensure effective implementation of policy. CASPR calculates similarity on each feature dimension separately to construct the feature matrix. For the similarity of security policies, where a subject is granted permission for a particular object, the corresponding value in the feature vector is set to 1. Then, we calculate the similarity of the policy feature. For other features, if the corresponding indicator exists, including past dependency or frequent simultaneous access or belonging to the same attribute, the value of similarity is set to 1. Combining the similarity of multiple dimensions, we standardize and normalize them. Afterwards, CASPR uses a K-means model for clustering the domains and the object types respectively. The K-means model calculates the feature vectors of the privilege sets that are classified into the same category, have more identical privileges. Especially, we perform secondary clustering for objects. It's because if two objects share the same object type but are contained in different classes, they will have different privileges. After obtaining the clustering result, we generate lists separately and calculate the intersection. It prevents badly recommending rules and ignoring differences between types. Policy integrity and availability require all the necessary rules to perform the behavior instead of adding one single rule to execute a certain operation. Therefore, we consider grammar and semantic anomalies, including constraint conflicts, policy inconsistencies, and permission incompleteness. We detect anomalies and enhance policy integrity from attributes, path dependencies, and permission sets. We employ CASPR in 6 operating systems to illustrate its universality. Each version of the SELinux policy contains a large number of rules. We perform attribute extensions to the policy rules and remove duplicate and clean data to obtain privileges. In each system, the performance of CASPR is satisfying. The average efficiency demonstrates that it's scalable and adaptable. From the clustering results, both domains and object types have an apparent clustering effect. We also use the sharp interpretable program, which explains the relevance of the features to the classification results. The policy feature is more decisive in determining identical privileges. When clustering new types, the attribute feature has less contribution. Based on the clustering results, CASPR recommends policy rules. We test the performance of CASPR at different granularity. When the performance is at its best, CASPR achieves 92.144% accuracy. Despite a few false samples, CASPR reduces the effort for manual configuration and makes a positive effort to narrow the attack surface. For the new types, the crucial feature of the policy is absent, causing its accuracy to be slightly lower. We compare CASPR with other two policy recommendation methods, which adopt different models and calculate different context-aware information. The results indicate that CASPR outperforms baseline methods. After recommending rules, we evaluate the effect of anomaly detection. Out of the recommended 97,583 rules, we identify 168 anomalies. Besides, we also artificially generate some set of rules to assess the effectiveness of anomaly detection. In conclusion, this paper makes the following contributions. First, we innovatively introduce context-aware information for privilege calculation and integrate them. Based on them, we propose CASPR, a rule recommendation and anomaly detection method. CASPR uses k-means model to cluster the domains and object types. Afterwards, it automatically recommends policy rules and detects and refines anomalies. Finally, we perform experiments to prove that CASPR with higher adaptability and feasibility. The average accuracy of CASPR exceeds other rule recommendation methods. Thanks for your listening. If you have any questions, you can contact the author.